Hello guys, welcome to the next part of the series. So in this part, I'm going to talk about how you convert your schematic into a PCB for you to design. Let me commit the project again. Perfect, everything's saved. So you will start by, just like when you were adding the schematic, go to your Home tab and go to Projects, or your project. And now, instead of creating a schematic, you're going to add a PCB. And let's call this the same thing, LM2596, and this will be saved as a PCB. So here, now in my source documents again, I can see this. And now, nothing's here yet, because I haven't imported anything. I need to actually import, I need to tell this software, okay, what do I want to import? Which schematic do I want to import? Now we only have one schematic, but you could have multiple schematics, so you might have multiple things that you're importing. So in this case, we're going to go Project. While we're in the PCB tab, we're going to go Projects, Import Changes from Buck Project PCB. Okay. And now it's going to say, okay, I have all these parts and all these connections. I want to validate the changes just like before. Looks good. And execute the changes. And look at that. All the parts have popped up. So the first thing I want to do is let's move these parts. You can just click and drag and move these parts onto your PCB. And that'll give you probably a better idea of how big we can make this. So let's kind of scoot these over into the corner. So I bet I can make the PCB maybe about this big. And let's start by reducing the size. So let's go board shape, edit board shape, and we'll just drag. Be sure not to get this anchor in the middle here, because that'll drag it down like this, and that really sucks. No one wants a PCB like that. Control Z will fix it. So grab it like in between the anchor points, and we'll go down to here, and we will go over to here. Perfect, and then click outside the box. And now you can see the PCB is a little bit smaller. While you're in this mode, by the way, Control and Scroll will zoom in. You will definitely be using that. Your right click will pan, so you can move around, and then your left click will select, and you can select, drag, and stuff like that. Those will be some useful commands when you're moving a bunch of stuff around. Alright, so it looks good. Now, let's say I wanted to change something on my design. Let's say I wanted to add a part. I'm going to add like a Molex or something. So I can probe the output 1x2. Maybe let's call that a header instead of a Molex. Alright, perfect. So you've probably seen these before. They're little header pins. You can plug your jumper wires and stuff into them, and in this particular case it's just 2 of them. So I'm actually going to place one of these at the output here, so that I can plug my jumper wires into this and get the power from it that I'm expecting, and much more easily I can plug it into my Arduino or whatnot. So we will add that. So now if I plug my Arduino into here, I'll get my 5 volts at the first pin and my ground at the second pin. It'll be a lot easier to actually utilize it. And you know what, let's even place this same thing at the input, spacebar rotates, so that we have our place we can put our power into as well. So let's do that. Add the ground. Alright. Save the documents. Control S will do that. We have to remember it's important to have designator names for this. So again, go to Tools, Annotate, Update the list, reset all, update the list, accept changes, execute changes. So now this has a name, star1 and star2. That's fine, you can call it whatever you want. In fact, I might even change it to J, because that's kind of a more common connector name. But it really doesn't matter. Let's save it. Let's compile it to make sure there's no problems. Looks good. And now let's go back here and actually import those changes again. So go Home, Project, Import Changes. Same thing, validate. Now some things are going to change, obviously, because you have different connections. That's fine. And execute. And now we're going to have these two extra parts in here, our input and our output port. A spacebar will rotate these parts again, just like before. And so now I kind of have all of the bare bones of everything that I want to do. And now I want to start routing. I want to start routing the different parts here. So the first thing, before we start routing, I want you to understand that a PCB has layers. And this particular PCB is a double layer. It has a top and a bottom. You can see on the bottom here, these are the different layers you can select. The top layer is orange in Circuit Maker, and the bottom layer is blue, so that when you're looking at the design, it's easy to see kind of which layer you're on. We'll be trying to do all of our routing just on the top layer for this video, but understand if you have a schematic or a PCB that you're designing that's multiple layers, you can switch between which layer you're routing just by switching top and bottom here. And so if I start routing while I'm on the bottom layer, it will route bottom layer. It will route traces on the bottom layer. Okay. Alright, so before we route, I want to do one more thing. I want to make sure that the trace width for my power pin is big enough. When you have a lot of power going through a wire, you need to make sure that the wire is thick enough, otherwise you can burn the wire. And in fact, you can Google something like a trace width calculator, for example. I've used this one before. So I know in my case, we're going to have a 1.6 mil thick trace. So the copper that is 1.6 millimeters thick. And because, for example, this buck converter is capable of 3 amps, let's say that in any particular case we could have up to 3 amps going through some of the power pins. So let's see what this thing suggests. Assuming ambient temperature and trace length, it suggests that we have a width of about 45 mil, let's just say. Now the only traces that will probably have current potentially that high is the Vout trace. The VN trace probably won't be that high, but it could be. So let's go to our design rules and go to routing. Actually, electrical, excuse me. Width, that's what I wanted. So routing and width, and we are going to create a new rule. So if I right click, I'm going to get a new rule. It's called width 1. But let's call this one VIN, because it's going to be for the input VIN net. And it's going to be for a particular net, not all nets, just a particular one. And the particular net is for the input net. I want to make sure that the input net is 45 mils min. So let's make all these 45. Maybe we can say we'll set the max to be, you got to give these units too, 45 mil. 45 mil, and we can make this one 100 mil. Perfect. We'll apply. So that's, and then we'll do another new rule, and we'll make that one Vout. We'll call that Vout. It's for the net Vout, and for this one we'll do the same thing. Let's make it 45 mil minimum. Typically 45 mil, that's fine. And our maximum will be 100 mil. Apply. Okay, so now anytime I route Vout or VIN, it's going to be 45 mils by default, because I've told Circuit Maker that's the rule. That's what it's got to be. And then any other trace that isn't any of those will be just 10 mil, and that's totally fine. Apply. Okay. So now let's start routing. So you can go Click up here, go to route. Now here is why it's super important to have net names. Now, if I didn't have a net name on this, it wouldn't be called vout or vin. It's only called vout or vin or whatever because that's what we ended up calling it in our schematic here. So we called this particular one vin. We called this one out. You can see all those names come back right here. So it makes sense as to, you know, pin 1 was vn, pin 2 was out. We can kind of self-check ourselves if we have appropriate net names. Alright, so now let's kind of, before we route, let's rearrange these into some way that makes a lot of sense. So our output is here and our input is here. Maybe, since we want our board to go this way, you know, our power is going to go in here and out here, we'll move it like this. So our input capacitor that's connected to Vn will go on this side. Our output capacitor that's connected to Vout will go on this side. We'll attach our inductor here. Maybe we'll rotate this. So we have our Vout here connected to our out pin here. And we'll rotate this one as well just to kind of keep it symmetric. And this guy, pin 2, right here. All right. This is our input, so we'll put our input next to our input capacitor. That looks good. Maybe move them closer. We'll put our output terminal next to our output capacitor. That's good. Let's rotate this so it looks like it's kind of in line with it. And we'll put our diode up here. We'll maybe find a better spot for that in a bit. All right, now let's begin routing. So let's zoom in a bit. Don't worry about routing anything that's connected to ground. There's kind of a trick for that. I'll show you it at the end. So we'll begin by hitting route. And now anytime we hit a net, it will kind of show us, hey, this is how we're going to be routing it, right? It will kind of automatically highlight the VN pin. So you see there's a VN pin, there's a VN pin. So we'll click from here to here and from here to here. That looks good. And our Vout escape will escape our route. Our Vout will go R on the keyboard is the keyboard shortcut, but you can also always just hit route. Go from here to here. All right. Escape, and from here to here. Perfect. All right, and Vout also gets connected up to here. Now let's say I do something weird and I route it around this, and I realize that that's not a very good way to route it, and I want to get rid of it. There's a couple ways I can do that. I can hit unroute the net. That'll unroute everything that's connected to this net. I don't necessarily want to do that, because these connections are all fine. It's just this one that's goofy. I can also unroute a connection. If I click on it, it'll unroute that. Or I can actually just select it. So let's say I had the bad connection again. I can select it and hit backspace. And if I do it a second time, it'll start backspacing all the way back to the source. I can also hit delete, but that'll only delete one of them. So I think a better way of routing it would probably be, I don't know, maybe something like this. I'm not really sure yet. Let's just say that looks like a good one. And, ooh, we're going to have a tough time getting to our output here. Maybe we can go around this way. There's a lot of important ways you're supposed to route. And you can see this one's a lot skinnier because it doesn't have, it's one of those general pins. It doesn't have to be, 45 mils like the other ones do. All right, so that's connected. And this doesn't have the right designator name. Let's see if I can fix that. So it could just be that it got all goofed up. Let's try doing that. All Let's try saving that and importing changes. Hopefully that'll change the name. No differences found. That's pretty interesting. Oh, you know what it might be? No, that might have done it. Okay, it might have just not been connected on this end. So let's save it and import changes. There we go. So now it's adding that extra net that we, that connection that we made. And you can see here it changed it, so now we have our output. And now that I see this, maybe it would be more appropriate to move it over here. Let's get rid of some of these. Maybe just redo this connection. And place him right about here. And we will route him just like we did before. Route him here, and then route him here. Alright, looks good. You can also kind of move these traces too. You can like pull them, you know, if you want to make them a little bit nicer looking. I do that a lot of times after I've connected them. Alright, and now I can even see that this board doesn't even have to be that big. I can probably move this guy a little bit closer. It's going to tell me I gotta reroute this, that's fine. Let's just delete that. I can probably move him a little bit closer, and I can probably move this guy a little bit closer. Make this PCB as small as possible. That's always desirable. Just like this. Perfect. Okay, so I was deleting that. Let's reroute that to here. Alright, looks good. So now this is a lot smaller. You can actually go back and modify this. Let's reroute our vout connections here. One goes here. One goes here. I'm sorry this video is getting so long. There's just so much to this part of designing a PCB that it's kind of hard to make it a shorter video, unfortunately. Yeah, that looks nice and pretty. I like that. Nice, good looking connections. Perfect. Okay, so now let's re-edit the board shape so we can make it even smaller, which is good. Make it smaller here. Make it smaller here. Make it smaller on this end. Now we're gonna have a nice small PCB, which is good. And the last thing I was going to show you was, there's a particularly useful way to connect all these ground pins, and it's called using a polygon. So if you click on the polygon up here, I want to connect the ground nets to each other. I'm going to do it on the top layer since that's the layer we're routing. Let's call this ground. Okay. And now I'm going to define the whole shape of the board. Let's say from here, each corner, 1, 2, 3, and 4. And now if I hit escape, see how it kind of fills the whole board in that isn't a trace with, well, what is essentially a ground connection. So if I look at this ground pin, you can see it leaches out to the rest of the board. And now everything that is just attached to whatever is in a net is now attached to ground. And so it easily attaches your ground pins, which is super useful because that's, all those have to be connected to each other anyway. The last thing we need to do is check our work, and we can do that. And when I say check our work, we just want to make sure that there are no floating nodes, and that everything here looks good. So let's save, Control S. Let's go to View, and I like to go View Single Layer Mode, and let's look at the outline. So the outline isn't any of the nets, and we don't see any of those yellow connections that show, hey, this has to be connected here. So let's pretend I forgot to connect this. Let's say I just delete that trace. And see I have that yellow connection there. Well, if I go to single view mode and go to outline, it's very obvious that that connection was missed just by looking at it. So that's why I like to do that, but you don't necessarily have to. So I see that I did something wrong. I will reroute it. Let's say I go like this instead. Escape. It's going to tell me, hey, you're going to have to report this ground thing, this ground plane. That's fine. So report, it'll kind of readjust it. And let's say I want to go kind of back to what I had it right about there. It'll do it again for me. So this PCB is done. If I kind of want to see what it's going to look like, I can also go in the View tab 3D mode. That's a lot of fun. And so this is the 3D view of what this buck converter is going to look like, give or take. I can flip the board and see what the back looks like. There's not really anything exciting on the back. But this will give me a decent little, display of what it ended up looking like, and it's always kind of fun. I'm going to go back to 2D mode, though, first. Get rid of single layer mode, and we'll do a rules and violations check. So I've already visually checked to make sure everything's connected, but there's some other rules I want to check. So if I go to Home and Design Rule Check, and say Run Design Rule Check, it could give me a couple errors here, but it looks like I got, so this kind of is the summary here. I got 0 counts on errors, 0 counts on warnings. Looks like all the rules are good. I have some violations, but it looks like that's probably in my schematic. Although, no, those all look good too. Yeah, so this looks good. There, it's probably something like I shouldn't have this on the outside and things like that. I can move these around a little bit, but other than that, the connections look good. This will be the end of probably the longest video in this series. But now you have your PCB and it's good to go. In the next video, I will show you how to generate a format so you can export this and actually make your PCB fabricated at a place like Osh Park or whatever. So let's file save all of our documents again and commit, so we actually send those back up to the cloud. Now we're going to be committing both the schematic and the PCB. So say OK. It's going to commit all the files, and all the green check marks means it is saved. So hope that was helpful. I'll see you in the next video.